Hello guys, welcome back to our channel. In this video, we will discuss the elements that shows exceptional electronic configurations. Now the electrons are filled in the orbital having low energy first and then start moving towards orbital having high energy. Now this rule was given by Aufbau. As we go down this diagram, the energy will increase, which means that the 1 is the orbital that have lowest energy and the highest energy orbital is 7p. So when we will start arranging the electrons in orbitals, we will start from 1s and then move forward. Now there are total of 118 elements in modern periodic table, out of which 20 elements shows exception. 10 are in F block, 10 are in D block, and there are no exceptions seen in S and P block. These circle elements are the ones that deviates from the general rule of filling the orbitals. The exceptions shown by D block elements can be explained by the relative stability of electronic configurations. Now the symmetry is the most important factor in all the atomic structures, and this is the reason why large unfilled energy subshells are unstable in nature and full filled orbitals are the most stable. So the answer to why this stability order is seen is symmetry. In copper, if we follow Aufbau's principle, the electronic configuration should have been Ar 4s2 3d9. But there is a way of arranging the electrons by which it can gain more stability, and that is by full-filled and half-filled orbitals. So the actual electronic configuration shown by copper is Ar 4s1 3d10. Here S is half-filled with 1 electron and D is fully filled with 10 electrons. Similarly, we can explain why chromium shows electronic configuration of Ar 4s1 3d5 instead of Ar 4s2 3d4. In this electronic configuration, we have attained half-filled S and D orbitals. Now try and find out the electronic configuration of these three elements by yourself using the same logic. Electronic configuration in Lanthanides and Actinides is far more complicated than what we saw in D block elements. But we will see a logical explanation as to why F block doesn't follow half-filled and full-filled orbital rule. Now the exception is seen in earlier lanthanides, and that is because 4f orbital is very close in energy to 5d and 6s. And also the radii of f orbital is more contracted, particularly for lanthanides. So the electrons that will enter f orbital will experience more repulsion as compared to 6s and 5d. So in lanthanum and cerium, the electrons will fill 6s and 5d orbital first to minimize the electron repulsion. In case of gadolinium, huge amount of repulsion is generated from pairing of electrons in f orbitals, and due to that, one electron gets promoted to 5d orbital, and that is the reason why gadolinium shows F7d1 configuration instead of F8d0. We can explain the electronic filling in actinium and thorium by same reason. The energy of 7s and 6d orbital are very similar, and 5f has very compact radii, and so to minimize the repulsion, the electrons will enter in 7s and 6d instead of 5f. And in protactinium, as the electrons are filled in 5f, the repulsion experienced by electrons is so huge that one electron jumps to the next empty 6d orbital. These are the electronic configuration of F block elements, and the exceptions are highlighted. Now there are still some exceptions that are hard to explain as to why do certain elements show certain configuration. But in this video, we have covered fair bit of the examples. For more such videos, make sure to subscribe our channel, and thank you for watching.